Welcome to the 2016 Alaska Fire Presentation Series. It is being brought to you by the Alaska Natural Resource and Outdoor Education Association, or ANRO. ANRO is dedicated to promoting and implementing excellence in natural resource, outdoor, and environmental education for all Alaskans. My name is Kathy Rezabek, and I would like to introduce our speaker today, Jennifer Barnes. For the last 13 years, Jennifer has worked as the Alaska Regional Fire Ecologist for the National Park Service and is located in Fairbanks, Alaska. She has a master's in plant ecology from Utah State University. Today she will be talking about tundra fires in a changing climate. Welcome, Jennifer.
Thank you, Kathy. So today we're going to be talking about tundra fires and how they may be changing with climate, and just getting some background on fires and fire ecology in tundra, and then moving into what the potentials are for the change in tundra fires, how much area might be burning, and what the effects of that might be. Most of my work has been in Anak and also on the Seward Peninsula, so we'll draw from some of those examples, and then also pulling in recent literature and some of the studies that have gone on in tundra over the last 10 to 15 years. The boreal forest and the tundra are adapted to fire. Almost 66 million acres have burned in the last 65 years, and that's almost 1 million acres per year. There's been a lot of question about how frequent fires are in tundra, and if you look at some of the older literature, most of it often said that tundra fires were infrequent and often small. Some of that is due to the fact that there was not good detection of fires. Sometimes they weren't found because they're fairly fast burning. And then sometimes it's just because some of the regions don't have as much fire activity up in the tundra areas. If you look at this fire history map, and these are just the fire perimeters, so larger fires that have occurred in Alaska, the majority of the fires actually occur in the boreal region. If you look at where the large fires and often lightning-caused fires have burned, our fire records mostly go back to about 1940. And these perimeters, as you can see, the color patches along here, you see in between the Brooks Range to the north and the Alaska Range to the south. You do see some fires down on the Kenai, and then as you look across into the tundra areas, you see fire patches along the Seward Peninsula, on the southwest coast of Alaska, and then also up in the Noatak and into the North Slope region. So although fires look like they're mostly occurring in the boreal forest, the tundra areas do have fires that occur. The fire history in Alaska is variable. As you can see from this graph that shows the fire records from 1950 to 2015, you can see time periods when there has been relatively small fires or fire years. This is the total acres burned. And then as you look towards the last 2 decades, since 2000, you see a lot more area has burned, and this is statewide for Alaska. So the largest fire season on record was the 2004 fire season, when we burned almost 6.7 million acres. The second largest fire season occurred just last year in 2015. The third actually was in 1957, and then the fourth was in 2005. One of the things that we're seeing with potentially our changing weather conditions and climate change is that we're seeing more frequency of large fire years occurring in Alaska. How this might be affecting fires in the tundra, we'll have yet to see. So when we look at a map that shows where we have tundra, and that's the brown area on this map, and that's using the circumpolar vegetation map, you can see that there's fires that occur down in the southwest on the Seward Peninsula, and then up in the Noatak in the North Slope region. Almost 6.8 million acres of fires have burned in the tundra areas. So a little about fire and how it burns in the tundra, and we can call it tussock tundra or shrub tundra. I'll show some examples of different types of vegetation types in tundra. But in general, tundra is considered a place where it's treeless, often has permafrost underneath, and they're cold sites, so it's kind of limiting the tree expansion into those areas. The fire behavior in these type of ecosystems are generally fast-moving, often wind-driven fires. They're considered a grass shrub fire, and they react a little bit differently than a boreal forest fire. The fire return intervals, and we'll talk more about this, can vary anywhere from 100 to thousands of years. And the fire return interval just means the amount of time between successive fires in an area. In general, if you read the literature or if you observe a fire after a year or even just a couple weeks after a tundra fire, the plants generally tend to resprout readily. They come back fairly quickly. This photo on the right-hand side shows a fire 1 year post-fire, and you see all of the Areophorum, or the tussocks, the cotton tussock grass, blooming abundantly because of the fire that occurred there the year previously. As I mentioned, the fire behavior in tundra, it tends to be a fine fuel-driven fire system, and that means that it's burning in the graminoids, which could be grasses and or sedges or tussocks, the dead grass, the thatch of that material, the mosses and lichens, and it also is being driven by the shrubs. But in a fine fuel-driven system, it's very responsive to temperature and winds, the relative humidity, and the amount of precipitation. Generally, these fires are going to be a lot shorter duration than what you might see in a boreal forest. So if you think about some of the fires that have occurred in the interior, these fires can often burn from June all the way until the snow flies in September or October. Most often, a lot of the tundra fires are fairly rapid. They'll burn for 1 to 2 weeks, and then either rain will come through and put them out, well, usually that's the cause of most fires going out in the tundra. But that is not always the case, and we may see, with climate change, longer duration fires occurring. So a little bit about fire ecology, and just kind of some basic background of fire ecology in tundra. The term tundra can encompass a lot of different vegetation types. You have across the top some examples of tundra that are more sedge component. The top left here are considered basically tussock shrub tundra, and this is another one. You can see the large tussocks here that are almost like bowling balls walking on when you go through it. And then this site over here to the right is basically frost boils. It's got some herbaceous plants and low shrubs, dwarf shrubs, and a little bit rocky. There's all sorts of different types of tundra when you call things tundra. The photos along the bottom are more shrub tundra. This is a low to dwarf shrub tundra. This one is primarily shrub birch or dwarf birch, and this is basically a willow shrub tundra. So how do these all look when they burn? All of these pictures are of similar vegetation types or of the same site, burned 1 year afterwards. These systems tend to respond fairly quickly and resprout fairly readily after a fire, but not always. You can see some of these areas that are more blackened still, and this had a lot more shrub component into it. And you can see the willows here, but there's some resprouting of those. These frost boils, the lichens across the top, the drier sites, burned in between these crevices that are formed because of permafrost. In general, fires are going to affect vegetation succession and distribution. They can also affect wildlife habitat. In Alaska, they can influence permafrost, nutrient cycling, the hydrology, and air quality. All of those are fire effects that we see after any type of fire that occurs. The tundra fire regimes Generally, it's one of the larger natural disturbance in tundra ecosystems. Generally, the season is between late May through July. You do see some fires starting in August, but that, if you're looking at lightning-caused fires, they're generally going to be May through July when we get our lightning storms coming through. I'll give some examples of some paleo studies that look at the fire regimes and how they vary in tundra, and I'll explain a little more about what these paleo studies mean. So I mentioned these kind of Arctic tundra areas in Alaska. We have above the Brooks Range, and you can see that there's not too much for fire history. These gray patches are areas that have burned. This is the Anak Tuvok River fire, which is one of the largest fires that's occurred above the North Slope, or above the Brooks Range there. The Noatak region, this is the Noatak River, and there's fairly frequent fire occurring in that area. And then on the Seward Peninsula, there's some very large fires that have occurred down there. A lot of the fires are actually from the early 1950s and the 1977. In recent history, we haven't seen quite as many fires occurring in that area. So there's been interest to figure out how common tundra fires really are, and one of the techniques that can be used is called lake coring. And we use this tool. Basically, it assumes that during a fire, you get charcoal that is given off from either the air or coming across through the water or across the ground and washing into lakes. And then you take these cores from the bottom of the lake where this charcoal has occurred, and the cores will get this layering of the pollen and also whether there was fires in that area. And so using that type of information, they can go back thousands of years to look at the vegetation and the likelihood of fire occurring in that area by just looking at the charcoal pieces that have fallen into the water or the lake that they cored. The Noatak has fairly short fire return intervals. The Brooks Range has pretty long fire return intervals. The North Slope has even longer, 3,000 to 7,000 years. And the YK Delta, which is that southwest area, has very long fire return intervals in between it from our past coring records. So what drives fire? Clearly weather is a huge driver in fire. The amount of precipitation, the temperature, the winds, storms, which can cause lightning occurring, and the humidity will also drive whether a fire burns and how it burns. The fuels are also important. The type of vegetation that's there and how dry. So if you have a grass type and it's been raining on it, it's probably not going to burn. But if you have had hot, dry weather and it's a bunch of dead thatch, it will probably burn fairly well. The other type of vegetation differences we're talking about for fuels is the differences between lichens or shrubs or these grass type vegetation. So all of that's going to influence whether fire will burn. And then clearly ignitions is also important. How much lightning is out there, and also people. Several of the fires on the Seward Peninsula are human caused. Most of the other ones, except there are occasional human caused fires that in the tundra, but because of the remoteness, you don't see the amount of it as you do along road systems, I would say. But climate change can impact all of these drivers. So if you think about climate, it's all the weather pulled together. Climate could also influence what vegetation is out there, and it also could influence the amount of lightning, and it may influence where people live or how they may start fires. So climate is going to be a huge factor in how frequent fires occur. In the literature and also, in the literature and on the news, you hear a lot about increasing temperatures, and we see it in Alaska, warmer summers, earlier summers, and certainly the prediction for Alaska is that we are in an unprecedented warming phase right now. So there's some studies here by Bott. There's several other studies that have come out since this paper that talks about increasing temperatures in the northern regions, in the boreal regions, or the Arctic regions of the Alaska and the rest of the Arctic regions. Another factor is shrub expansion. How will that change our fires in the tundra area? How will it change the vegetation that's there, and how will that change how it will burn? And will the shrub expansion outcompete the lichens that used to be there? These are all questions that are coming from current research about the conditions in the Arctic tundra. So clearly some of the impacts of climate change on fire, and this goes for almost anywhere you look in where fire occurs, is that you may see increased area burned and an increased number of fires started. All of this can result in shortened fire return intervals. So if you burn an area and then it burns again, you're going to have these shortened fire return intervals. There's also potential that it's going to increase the severity of fires, and I'll give you some examples of burn severity in a few minutes here. And there's also potential for the changes in fire season and the duration of fires. Are we going to start seeing fires starting earlier, or are we going to start seeing the time, the length of how long the fires burn, particularly in tundra, will we see longer duration fires occurring? This study from Young et al. In 2016 shows models predicting using temperature and the PET, which is an precipitation evapotranspiration, as a model, and forecasting with our predicted climate change, how we might see changes in our future fire regimes in Alaska. And if you look across, the top row has the global climate models there's 5 of them pulled together, but you can see that there's a lot of red, dark red, which means that they're predicting more fires to occur in 2007, or in the next decade, or 100 years, excuse me, up in the northern regions of Alaska. They also have, if we use the coolest GCM, it doesn't look quite as extreme, but definitely from this paper, they're suggesting that we're going to see an increase in fires in the tundra area. So are we seeing that, or will we see it? One of the things that definitely struck us, as I've mentioned before, the no-attack region definitely has a lot of fires. But in 2010, we had over 40 fires that occurred, about 37 within the no-attack National Preserve. And this was a record for the park area over the last 60 years to have that many fires occurring. Not all of them were large. You can see the red perimeters of the fires, and some of them remain fairly small. But is this going to become more common? It followed up by 2010. There was a large fire season in 2012 in this region as well. So potentially we will see more fires occurring. I mentioned about shortened fire return intervals, and that is where areas are burning beyond what they naturally do in the fire regime. And this map shows the red perimeters. The red areas are where all of the fires have occurred since 1940, or what we have mapped. And the yellow are showing places where it's burned, yellow and orange are showing places where it's burned multiple times. So that's basically a 60-year fire return interval. But yet most of our tundra areas, we don't expect fires to occur more than every 100 years. So if we look in, you can see it up here in Noatak, there's some areas of yellow. There's a area over here on the Seward Peninsula where it has been burning multiple times. And so that was noted in Kyle Jolly's paper in 2010, that the tundra areas definitely seem to have lots of repetitive fires going on. In the boreal forest, it's something that has definitely raised the concern of managers, fire managers, and land managers as we kind of utilize old burns as a fuel break, and we expect that if a fire burns up to a recent fire that it's going to slow down or stop. But if these are no longer working as fire breaks, that's of concern. And so there's currently some research going on looking at why is it and why are they burning that way and why are they burning into these recent fires. So burn severity and fires. Burn severity is probably one of the biggest drivers of effects of fire, both from the vegetation, also from the soils, also potentially water quality. All of that can be affected by what the severity of the fire was. One of the things is the terminology of fire intensity and burn severity can oftentimes be confused. Generally, your fire intensity is when the fire is occurring right during the time that the fire is burning, and it's often a description of what the heat was, whether it was a surface fire or a crown fire, or whether it was smoldering and how long of time it was residing in that area. Fire intensity will also result in the combustion and the emissions that are given off of a fire. Your burn severity, on the other hand, is more the effect after the fire. One of the things is that, if you have a 100,000 acre fire, it doesn't all burn in one type of severity. It's variable across the landscape. And the burn severity is going to affect your ground vegetation changes, and it's also going to affect organic soil consumption. And all of this will then ultimately affect what happens at that site, your plant establishment, your thaw depths or your permafrost, and then other ecosystem services. So, what will happen to the berry production and or your wildlife that might use that site. So burn severity is important. And to give you some examples in tundra of what we mean by burn severity, the top photos are a high severity site. These little knobs that you see are remnants of tussocks that have burned with such high severity that they can't resprout. All of these photos are all 1 year post. So normally, right after the fire, they're going to resprout. And if it burns so deep and deep into the soils, it will kill or can kill these tussocks. We don't see a lot of that in tundra fires normally, but we may see more of that. Moderate severity, generally you're going to burn in between the tussocks, maybe kill a couple of them, and you'll burn through those shrubs that are there. Those will burn. And then these are kind of an unburned site, what it would look like without fire in it. But the severity is also going to influence your how much is consumed in the organic material. And if you hear news or you hear about carbon release and ancient stored carbon, that's from these organic soils. So these are dug down into the ground, and this is mineral soil here, and this is basically decomposing plants and moss material that's been charred or burned off of the top, and there's very little of this left. On a moderate severity, it's going to burn down a little bit more, but not as severely as a high severity site. And here's one that's an unburned soil and moss organic monolith. So the question of how do fires burn? I mean, what kind of severity do we see in these tundra fires? We've done some work with the Park Service, and there's been other work done by Nancy French and Tatiana Loboda looking at burn severity and seeing how it how these satellite mapped severity maps are working in the field. And this map shows basically an example of the red areas are higher severity. Here's a field site that matches up to that. The light yellow and orange are low moderate severity. And if you look at this map, a majority of it actually is low or unburned severity for this fire from 2012. When you use this monitoring trends and burn severity data, just kind of out of the box, this is what they show. A majority of the fires are low to moderate severity. So, and this seems to be the norm, at least of what I've seen in a lot of fires, is it's not burning real high severity. But what might we see in the future could look something more like this, which is the Anak Tuvok River fire up on the North Slope, where a large majority of the area burned in high severity. And part of the reason was because this is a very late burning fire. It burned all the way from, I believe it started in June and burned into October, and it had the soils and the organic material were drying out, and as a result, they saw some pretty high severity sites in this area. So this could become more common, and which could be a little more problematic. So the other thing with climate change is we might expect changes in the fire season and the duration of the fire. Some of the studies being done in the Arctic Network by Dave Swanson are starting to show some trends of snow off occurring earlier in the Arctic Network area of the Park Service. And this could influence when we might get fires. Obviously, we won't have fires occurring if there's snow on the ground, but if it's starting to see earlier springs or later with snow off in the fall, that could influence when we get our fires occurring. There's lots of papers and discussions about the warming records, so the temperature records in the Arctic, and seeing an increase of that. And then, as I mentioned with the Anak Tuvok River fire, seeing these long duration tundra fires, a fire that burns from June to October in a tundra fire is fairly unprecedented, and clearly also had some impacts on that fire. And then there's also been discussion about more lightning occurring in the tundra regions. This graph, which just goes to 2007, is for the North Slope ecoregion and showing the number of lightning strikes by year, but you see this large increase that's occurred. And some of this is because we've got better lightning detection going on, which is helping detect more lightning. But there does seem to be discussions and talk about more commonly seeing lightning in the North Slope where they hadn't seen it before. All of these will influence how much fire burns. So from the implications of an increased fire landscape, clearly there could be some effects on the vegetation and soils and permafrost. These could also influence wildlife habitat and subsistence resources. And then also, of course, there's concern about carbon emissions, and are we feeding the system by putting more carbon into the air? And are we releasing ancient stored carbon in tundra when we have these fires? When you think about, or when I think about the studies of fire in tundra, there's a lot less material about the impacts of fire in tundra areas than there are for the boreal forest. So there's a lot of kind of new information coming out, and probably some areas that we need to get more information on how do fires impact our landscapes. So as I mentioned, vegetation changes is a potential for increased fire. And as I've also said, the severity of fire is very important. So what happens after a fire is going to be dependent on the severity of the fire, the pre-fire vegetation, what was there on site before it burned, and then the seed sources that are available. And all of these will influence what may happen at these sites. I'm going to give you a couple graphs just showing how severity influences what vegetation is there. And these are all 1 year post-fire. So in the unburned plots that we had, the Eriophorum and Carex, which are tussock-forming sedges, were about 60% cover in the unburned. The low severity was more in the 45%, and you can see it dropping down. But even in the high severity sites, we still had a fair amount of cover. You can see these tussocks are resprouting 1 year post-fire. But the one thing that is striking is the grass cover. So in these high severity sites, we're tending to see grasses, which are different than these sedges. So that may be one effect of these high severity sites, is having more grasses occurring after a high severity fire. Again, 1 year post-fire, looking at shrub cover, you can see as the unburned, and these low shrubs include Labrador tea, dwarf resin birch, blueberries, and willow. Our cover of some of the plots that we had that were unburned was about 45%. And even in the low, moderate, and high severity, it starts dropping pretty rapidly. So it's burning those shrubs fairly readily. But they're still there. They're resprouting. They're coming back after the fire. But in 1 year, they're still pretty small. Dwarf shrub cover, that includes cranberry, cloudberry, blueberries, crowberry, and bog rosemary. Again, a fairly large drop even with the different severities, but you see that they are still present at 5% at high severity. So those are just really small little starts that are there. I have a couple photo series showing fires after a couple different, well, this is moderate severity. So we had in 2004, and this is actually about 2 weeks after the fire occurred. Actually it's 3 weeks after the fire occurred. It's already greened up, so that's that upper left place. The 2005, 1 year after that fire, you can see the tussocks are blooming, the cotton grass is blooming. They often tend to have this flush of flowers, and they actually are setting their seeds on the Eriophorum the year before. So they're setting their seed and then bloom, or setting their inflorescence the year before, and then they're blooming the following year. So this fire caused this to put flowers out for the following year. In 2007, so 3 years after the fire, and just in 2013 we went back to these same sites. And what we did find is that they tend to almost have the same composition as some of the control plots that we went to. There's not a lot of difference in them in the vascular plants, but the difference are the non-vascular plants. The mosses and lichens are not the same anymore there. This is another example, same series of one few weeks after the fire, a year after the fire, 3 years after the fire, and 9 years after the fire. I think I said 11 on the last one. But again, responding fairly quickly after fire in these situations with moderate severity fires. Chuck Racine was one of the early pioneers with looking at tundra fires. He established plots after the large 1977 fire season, and happened to also put some plots in in the Seward Peninsula, and then also in the Noatak. And this one was actually a fire from 1981 or 82 that they put in. And we went back and re-monitored those, And you can see, again, in these shrub tussock tundra, they're looking pretty similar. There's not a lot of change after 20 or 12 to 20 years. They're kind of back to the same in the vegetation composition. And there's other studies that have shown this. But the changes that can occur are in places where you might have high severity fires. So this is a racine plot that was put in Nimrod Hill on the Seward Peninsula. And pre-fire, it was a dwarf shrub tundra, and it burned fairly hot. You can see the severity of this fire in 1977 fire. It burned, and there's basically bryoids and sort of a dry site. And they went back, and 6 years later, it's a sedge meadow, and 28 years later, by the time we go back, it's willow shrubs. And that's a big change, going from a dwarf shrub type to a willow shrub type. Part of the reasoning behind this is because of the severity of the fire. The soils were available for seeds, for the willow seeds to blow in here and establish, is my guess on what had happened in a lot of the site. There were willow bands just off to the other side, but the severity of the site definitely influenced what vegetation was coming back. So vegetation is really just wildlife habitat, and this is probably an area where we need more work done on a variety of species in the tundra areas and the impacts on fire. But certainly there's been a lot of work, and we'll talk a little more on the caribou, looking at caribou habitat and fire effects. And there's been some recent paper that came out on the moose in Arctic areas, and that potential increase of habitat for moose. But probably less studies have been done to look at fox or snowshoe hare or the birds or impacts of bears. My guess is that for the most part, these species, the snowshoe hares would probably do well with fires, and the birds, depending on where they're nesting, is going to probably depends on, I guess, basically the nesting habitat of the birds. The fox will probably do well in response to snowshoe hares, and then also voles can be prolific after fires. But that's one area. There's more studies in the boreal forest, but less has gone on in the tundra areas of effects on wildlife. I think one of the clear studies on fire and fire effects on wildlife is both with caribou and moose. Kyle Jolly and others have done a fair amount of studies looking at the Western Arctic caribou herd, and have radio collared caribou and looked at places where they're avoiding going to because they are looking for the winter browse of lichens, and if it's burned, it's probably not going to have that much lichen in it. There's a lot of literature out there by Kyle and other folks that have studied the effects of fire on the winter caribou browse. That's this lichen shown in this middle picture here. There's a recent paper by Ken Tape and others looking at range expansion of moose in Arctic Alaska and looking at climate change. If we start to see more willow in the area, we will likely, it may be a boon for the moose. So more work needs to be done definitely in that area. So I guess to finish things up, we'll go into the carbon, the question of carbon, stored carbon emissions and age of organic soils. I guess going back to this photo here, this is a organic soil sample that was taken in a tundra area, and you can see that it's almost 20 centimeters deep. And this is what they're talking about, the storing of organic and old carbon are in these organic soils. And so we had a study that looked at how old are these the carbon, this plant material is decomposing plant material. How old is it? And are we actually burning old carbon? There was some work initially done by Michelle Mack. She found up on the North Slope that area was burning primarily younger carbon, and our work in NOAATAC is also showing similarly that most of the carbon was less than 50 years old on the surface that was getting burned. But as you get into these more high severity or areas that have burned multiple times, it's projected that these carbon would be much older, in the ranges of 600 to 800 years in age. So we're working on a publication on that currently. So as I mentioned, the organic soils that Michelle Mack and others collected, they found that most of the organic carbon that's being emitted is young, but potentially these deeper organic layers are going to have older carbon. Another concern, obviously, is the emissions. Mack and others projected that almost 2.1 teragrams of carbon were emitted from the Anak Tuvok River fire, which is a lot of carbon. It's almost 2.3 million tons, and that's of concern, obviously, if we're emitting that much carbon into the atmosphere. So last is a little bit about fire and permafrost. Clearly, burn severity is going to have the impact on permafrost and thaw, so that insulating organic layer, if that's all burned off, you're going to basically have more thawing occurring, and more work has been really done on fire effects in permafrost in the boreal regions, but we're starting to get more research on it in the tundra regions. But in general, if these sites have a lot of ice richness, a lot of water to them, there's going to be a greater impact post-fire. This example shows areas where the hydrology has changed. These are actually from boreal forest sites, but the hydrology has changed in this area due to the permafrost thawing after a fire. There's also concern of methane release as we thaw some of these frozen grounds in the tundra, and also burning into the deep peat layers and peat bogs from Canada. There's some studies showing, as we're burning these old peat bogs, that there is a fair amount of methane released from the fires going through there. So just to kind of summarize what's gone on, or how we see fire affecting tundra, and generally we see low to moderate severity is the norm for tundra fires, but we may see changes in that. Even in the high severity sites from the Anak Tuvok River and some of the places that we've seen in NOAATAC, we still see resprouting occurring, and we probably have a pretty resilient system for the vascular plants, which are the shrubs and grasses and graminoids that are out there. But the largest change is going to be to the non-vascular communities, the mosses and lichens, and that's because they're consumed often in the fires. They're the top layer, and they're also the things that dry out. Some of those lichens and some of the mosses take longer to regrow back into a site. So that definitely will change as as we see more fires. And we may also see, with warmer temperatures, vascular plants, shrubs, overtopping the lichens and basically outcompeting the lichens. There's studies going on that as well. We may see some grass increase. Grass is increasing with high severity fires, and then in some situations we may see shrub increasing after high severity fires, or just with increased temperatures we may see shrubs more likely to occur, and certainly increases in alder are a huge part of some studies in the tundra areas. How will alder influence the fires? Definitely with increased temperature and lightning, we will definitely, more than likely, we'll see more fires in the tundra areas. And this rapid fuel biomass regeneration, the ability to regrow fairly quickly after a fire, means that these areas could burn fairly quickly again, in 5 to 20 years. And we're seeing that type of fire return interval already in some of the regions of tundra. The organic soils are definitely vulnerable to fire, and they're going to be more vulnerable with increased fire frequency and increased severity of fires. So climate change is going to impact the extent, seasonality, and the effects of fires. So I'd like to thank you for joining us, and this concludes my presentation for today. And please tune in for other presentations on fire at ANRO. Thank you.